Hello guys, welcome back to TMS Solution YouTube channel. So I'm always so great with you. So let us look at how can we find the limit of a cross product. Now let's say we have these two vector valued function here. Let me say you want to find a limit such that t goes to 0 of the cross product of these two vector valued function. So we can find the limit of each component here. So the limit when cost goes to 0 of a cost of t plus, now this is I, a limit of sine of t such that t goes to 0. Now this is j, and then plus a limit such that t goes to 0 of e to the power of 2t. Now this is k. So for this we can directly substitute 0 into a cos of t. So a cos of 0 we know is 1. Okay, and then so remember these are vectors, and then a sine of 0 is 0. What about here? Remember everything to the power of 0, because if you substitute 0 here, everything here will become 0, and then e to the power of 0, it's 1. Okay, so here we started. Let me just delete this one. Now let's find off the second vector value function here. It's a limit of 2 such that t goes to 0, and this one is of a limit. Remember the second one, we have t so that t goes to 0. Now this is I plus a sine of t when t goes to 0. Now it's a limit, then j, and then cos don't forget it's a limit, then this is chi. Now here we can also direct substitute here. If you substitute 0 here, it will be 0. If you substitute 0 here, remember last time it was 0, so it's 0. Then if you substitute 0 here, it will be 1. Now we will find the limit of each vector valued function. Now we need to perform a cross product for these limits that we got here. Okay, now the limit of R1 dot R2 such that t goes to 0 would be, let's say, I, j, k. Then the cross product we need to perform here, 1, 0, 1, then 0, 0, 1. So here we need to perform a cross product here. Okay, I hope you all know how to perform a cross product. So when you consider I, then I will be I, then we remain with 0 1 1 0 0 1 1 0. Okay, minus a j, it will be something like this. Okay, we remain with 1 1 1 0. Okay, plus a k. Then what will remain if you cover this one and then this one will be 1 0 0 0. Okay, now it's becoming easy here. 0 times 1 is 0, minus, remember, is this one minus this one. 0 times 0 is 0, minus 0 times 1 is also 0. So in this case, let me say it's 0i. So it's 0i here, and then minus 1, this one times this one. 1 times 1 is 1, minus 0 times 1 is 0. So let me say it's 1 j. Okay, then plus 1 times 0 is 0, minus 0, this one times this one, 0 times 0 is 0, so this one is also 0 k, right? So the final answer here, which is now the limit R1 dot cross product of this one such that t equals to 0 is, no, this one is 0, this one is 0, so it will be j.